you all are doing well. So this question appeared in CSR UGC Net Maths, June 2018. So in this question, we were told that lifetime of an electric bulb follows an exponential distribution with mean hours theta, and we want to estimate this theta. Uh, so in order to estimate theta, we were given n bulbs that were switched on at the same time, and after t hours it was noted that only n minus m bulbs were functioning, and all of that other m bulbs were having their lifetimes as x1, x2, x3 till xn. So given this data, we want to estimate maximum likelihood of theta. So let's get started with the solution. So we know that the PDF of an exponentially distributed random variable with a mean theta is given in this form: f of x given theta 1 upon theta e to the power minus 1 upon theta x, where x is greater than 0. In the same way, you can see the CDF of given in this equation. Okay, so now we want to estimate the life. So since the lifetime of a bulb follows um, an exponential distribution, for m bulbs, we were given lifetime to be x1, x2 till x3. So for each ith bulb from 1 to n will follow this distribution, which is written in equation 3. But we are not given lifetime of n minus 1 bulbs, which are still functioning. So we assume that their probability or their lifetime will be greater than t. That is, we need to find the probability of each n minus m bulb that their lifetime is greater than t. So using CDF, we can easily find that. Since we know that CDF is given in this form in equation 2, so we can use this equation to find for time greater than t. Okay, so now we have equation for PDF of the lifetime as well as probability that that n minus 1 bulbs will have lifetime greater than t. So so the given this data, we want to estimate theta. We will, since all of these bulbs are identical and independently distributed, sorry, since the distribution, since the lifetime of all of these bulbs is identical and has independent distribution, we can find the likelihood function for theta to be in this sense. We will product each of the PDF of m bulbs, and we will product the probability of lifetime greater than t for each of the n minus 1 bulbs, and we will obtain this equation. So since we want to find theta, and this expression we have calculated is an exponential, so using log will be beneficial to us. So if we take a log of this likelihood function, we will obtain an expression which is easier to interpret. When we Since we want to find the maximum likelihood estimation of this theta, we will find the maxima of this function, which is nothing but the first derivative of this expression that we found, and we have to equate it to 0. On solving this equation further, we will have estimated mean, that maximum likelihood estimate of mean, to be this.